explain to you about the theoretical for this experiment. There are three types of heat transfer. The first one is conduction, the second one is convection, and the last one is radiation. In this case, I can say that the radiation doesn't include in this process, because the distance between ice and lamp and other electricity is far enough, and also for the conduction. There is no medium which can transfer the heat to the ice except when the ice melting and the water has been there in the medium. So, the only type of heat transfer that can happen first on the ice is convection. As you can see in here, there is a condition of the experiment. So, because there is no force in the experiment, we can say it as natural convection. For calculate the heat transfer in convection, we can use this formula as well. So the first thing that we must do is finding the value of H, or coefficient convection. This is the table of the reference books, which are Chengel and Gankoplis. So in this experiment, I just using two types of physical geometry based on the table, but actually it is three shapes of ice. The two shapes of ice, which are the cube and the block, is included in horizontal plates because the length of them isn't more than 1 meter. In process of finding convection coefficient, we must find Grashof number first from this formula. And for finding the all constant in the formula, we can use the table. And this is the dimension of ice for each shape. Before we find all the constant in the table, we must find the film temperature, which we can calculate it by calculating the average of wall temperature of ice and air temperature. After that, we can find it in the table. Because there is no 12 degrees Celsius, so we must find it by interpolating. And we get the result as you can see in here. After we get all the information, we can calculate the Rayleigh number, which is multiplying the Grashof number and the Prandtl number, and we can get the result in here. After that, we find the right equation for the constant of convection, which is for the cylinder is this one, and for the horizontal plate is this one. After all the calculation, we get the result in here for the coefficient of convection. So the next step is finding the values of heat transfer for each shape. Before it, we must know the surface area of each shape. So this is the result of the calculation for it. After it, we can calculate the heat of each shape, and this is the result. So as you can see in here that the heat from the block ice is the highest and cylinder is higher than the cube, so that's why the block ice is faster in melting than cylinders and cylinder is faster in melting than the cube. What is the benefit we are knowing these cases? The first one is knowing what shape of ice that we must make. Why is so important? Because it has the implication it will save the energy of electric. And of course, if we are knowing it, it also can save our money for paying the electric, especially in industrial scale. Okay, so this is the last of my explanation. Thanks for watching. See you.